Okay, so I am back with another revision video for O-level math students before the P1 exam. Today's topic is transformations. What I'm going to do is I'm going to revise a bit of transformations and then take you to the then take you to some past paper questions from paper one, and we'll see how to handle those questions. Some of those questions will certainly be tough, so we will learn how to solve them. Remember that if transformations can come up in both papers, if it comes up in paper one, it's unlikely that it's going to turn up again in paper two. That is not to say that it can't, but that's the general trend that whatever topics come up in paper one, they don't come up again in paper two. So let's talk about transformations. There are two types of transformations. These are called isometric and non-isometric. You don't really need to know the name, but you should understand what it is. It preserves shape and size, isometric transformations. So translation, reflection, and rotation. The size of the shape that you're transforming stays the same. And in enlargement, the shape and or size just changes. So enlargement, you'll see the shape getting enlarged. That is what non-isometric transformation is. I don't know why this is happening. Okay. Just give me a moment. I think there is an issue. Okay. So first of all, translation is movement along the x-axis and y-axis. It's described using a translation vector. So you have movement on the x-axis and movement on the y-axis. Then when you're translating, you start from the object and move according to the vector, and then you reach the image. That's how you do your translation. Then there is reflection. It involves the line of reflection. The perpendicular distance between line and reflection and object is the same as the perpendicular distance between image and line of reflection. So you will see a basic line that separates the object and the image. We'll learn how to do that. Object and image are on opposite sides of the line of reflection. That's obvious. Orientation is not preserved. Now, what does orientation mean? When the labeling is done, it's labeled like that, A, B, C, but the image will have the orientation D, E, F. So right now I'm moving clockwise. For the other one, I'm moving anti-clockwise. That is what we mean by orientation. Why is this important? Because sometimes it's confusing to distinguish between a reflection and a rotation, and that's where the orientation comes in. Okay, then you have rotation. It involves the center of rotation, angle of rotation, and direction of rotation. Those are three things. So whenever you're describing a rotation, those are the three things that you need to take care of. Use vectors. I use vectors to do the rotation. A lot of people have a lot of different ways of doing it. It's up to you, whatever way you've learned and whatever way you find easiest to use, that's what you go on and use in rotation. There is no harm in using compass and Ds and so on just to rotate, and tracing paper to rotate. That's absolutely fine. Then what you do is, whenever you're constructing vectors, you first travel from the center of rotation to the object, note down your vector, then you use the following rules. So if it's a 90-degree clockwise rotation, you write A and B first, whatever those numbers are, you exchange them, and then you change the sign of the one at the bottom, and then you use this movement to point out the rotation. I'm going to do that in a bit. 90 degrees anti-clockwise rotation looks like that, and 180 degrees is simply just switching the signs of A and B. Okay, then there is enlargement. I will do the rotation for you in a bit, and we will see how that works. Enlargement involves the center of enlargement and a scale factor. Scale factor is the positive when object and image are on the same side of the center of enlargement. It is negative when they are on opposite sides. So you start from the center and travel to the object again. You multiply it with the scale factor, so then uh, you reach the image. Then there's matrices involved. So transformation matrix multiplied by the object matrix gives you the image matrix, and that is what will happen. Let's try to do some questions, and I will point out whatever needs to be pointed out when I am doing all of these questions for you. These are questions from some of the more recent past papers, starting from uh, I think they start backwards, or they start forwards from June 2019. Okay, that's the first question. You see two shapes being drawn, A and B. Shapes A and B are drawn on the grid. Draw the image of shape A after a translation with vector -4 and 1. So this is a movement on the x-axis, and this is a movement on the y-axis. So I have to take A and move 4 units to the left and 1 unit up. So I'm going to start drawing 1, 2, 3, 4, and 1 unit up. So this point has come here. So what I can do is I don't really need to count every other point. I can just say that this point is moved here. The shape is going to remain more or less the same. And that's how I'm going to draw it. So the shape remains the same. It's just that there's a movement. I can also verify that I have moved -4 and 1. I have moved -4 and 1. So that is how it's working. So label that, draw the image of shape A. So you just write down that that's the answer to part A. Draw the image of shape A after an enlargement with scale factor -12 and center 1, 0. So always when you're doing such questions, just mark your center. 1, 0 is this coordinate. So what you do is you go to every other point and then you note down the vector. So let's say I was going to this point first. What movement am I doing? I am doing a movement 0, -2. What I'm going to do is I'm going to multiply this entire x and y coordinate both by -12. So if I do -12 into 0, I again get 0, and -12 into -2 gives me 1. So my image for this point will basically be at this vector. Let's plot this. So 0, 1, I have to have a movement of 0 and 1. Okay, so that's my new point. Let's mark that with a different color so that we understand it. Then let's look at the other movement. Let's try to move to this point. What am I moving? I will first move on the x-axis and then on the y-axis. So I am moving 2 on the x-axis and then -2 on the y-axis, multiplying both by -12 again, -12 into 2 and -12 into -2. What does that give me? That gives me -1, 1. So where do I have to move? I have to move -1, 1 from here. So -1 and 1. So that's the point that I get. Then I'm going to pick out another point and do the same movement. This is a 2-mark question, so it's going to take me a bit of time to do it. I move down. That's 5 units. That's 0, -5. Sorry, no, that wasn't my starting point. Oh, I missed out on my center of rotation. That's my center of rotation. Let's just mark that. So 0, -4. So that becomes what? It becomes again -12 into 0 is 0, and this becomes 2. So I will then plot a movement of 0 and 2. So that's my other point. And then this last point, 4, -4. So I get -2, 2. Okay, so that is my image that I need to draw. You see the scale factor was -12, so it has shrunk in shape, and it sort of also has inverted its shape completely. Okay, I can erase the rest of my working. That is my answer to part B. Then it says shape A is mapped onto shape B by the single transformation P. Describe fully the transformation P. So when I am describing fully the transformation P, I am looking at these two shapes. Now, since it's inverted like that, that tells me that a reflection has happened. So the first thing that I'm going to write is a reflection. Now, since it's a 2-mark question, you got that 1 mark. What is the next mark for? It's for writing down correctly the equation of the mirror line, or what the mirror line is. So what is it being reflected upon? I think that's pretty clear right now, that it's the x-axis. If it isn't clear to you, what you do is you pick out any object and you pick out any image and you draw the perpendicular bisector of that object image line, and that is the line of reflection. That's a long idea, I don't want to go through that here. So reflection in the line in the x-axis basically, or y equals to 0. That's the equation for the x-axis. Then it says find the matrix representing the transformation P. So whenever you're constructing matrix, you start off with this original matrix 1 0 0 1. This represents what? This represents basically 2 points that you've thought of here and here. You think about the transformation that you just described, and you try to figure out that if this transformation was happening to these 2 points, where would they move? So the first point would be on the line of reflection, so I'm going to say that this point remains as it is, so I'm going to write 1 and 0. This other point would be reflected down here, so I'm going to say that it moves to 0 comma minus 1, and that's going to be my other column. So that is my answer for the matrix. Whenever you are thinking about the transformation matrix, you always think about the points 1 0 and 0 1, and you apply that transformation, whatever you've described, to these points to get your answer. So that's the first question, relatively long, and let's see. Then it says describe triangle A and triangle B in the next question are drawn on the grid. This looks like a simple translation to me. So that's what I'm going to do. I'm going to first describe it's a translation. And what other thing that you need to describe is the translation vector. So what that maps triangle A onto triangle B. So do you see a movement happening? Let's pick out one set of points. It's gone up here. So it's moved -3. So I'm going to write translation with vector -3. And how many points have I moved up? I moved 4 units up, so I'm going to say -3 and 4. Draw these with a pencil so that you can erase them and then find out what the final draw your final answer clearly. Triangle A is mapped onto triangle C by an enlargement with center 0 3 and scale factor -2. So 0 3, let's first go on and mark our center of rotation. So 0 3 is somewhere here. The scale factor is -2, which means that it's going to be on the opposite side. So I'm going to somewhere see it somewhere here. I've got to pick out each point and measure the x and y. So this one is -1 and -1. I'm moving backwards. What do I need to multiply it with? I need to multiply both with -2. So this becomes 2 comma 2. So what I'm going to do is I'm going to move 2 comma 2 and plot this point. So 2 comma 2. Okay, so this point has moved here. Then let's pick out another point. Let's pick out this simple point. It's just a movement of -3 and 0. So I'm going to multiply that and I'm going to obtain 6 and 0. So that's 6, 3 and 3, 6, 3 and 3, 6. Okay, that point moves here. Then -3 and -1 gives me 6 and 2. So 6 and 2 gives me here. So that's the enlarged shape. So remember that you're always moving from the center of rotation, center of enlargement. Let's see, I can erase the rest of my work. That's question number 2. Let's look at question number 3. It says triangle A is mapped onto triangle B. You can clearly see an enlargement. I can see that there's a positive enlargement factor because they look on the same side. It's not inverted either. Complete the description of the transformation that maps triangle A onto triangle B. So there are 2 things that you need to describe. You need to describe the center of rotation and the enlargement factor, center of enlargement and the enlargement factor basically. So I can see that they are on the same side. It's not inverted, so it's not negative. What I can do is I can simply say that the length of this is 2 and the length of this is 6. So the scale factor must have been 3. Scale factor is 3. So 2 became 6. Therefore, the scale factor is 3. And center of enlargement. How do you find the center of enlargement? What you do is you connect the object with its image. You take one set and you connect the object with its image, you draw a straight line through that. Okay, oh, way back. Okay, that's an approximate line, it's not passing through that. And you pick out another object and image. When you join these two, you find out what your center of enlargement is. My lines are really not up to the mark. We just draw more exact lines so that we can see what is happening. Nope. Not happy with this one. So that's the center of enlargement. What are the coordinates? It's 4, 2. So center of enlargement is 4, 2. So that's drawing two object image lines to find out your center of enlargement. You can erase them then so that you can do the plots as well. Then triangle A is mapped onto triangle C by reflection in the line y equals to minus x. So what does the line y equals to minus x look like? Let's first draw those. It passes through 0, 0 and is negatively sloped, and it passes through those coordinates 1, 1, 2, 2, 3, 3, one with a negative and one with a positive. Why? Because for every y that's positive, x has to be negative, and for every y that's negative, x has to be positive. So that's the line y equals to x. Okay. I want to draw triangle C. Remember that reflections are perpendicular. So when you are trying to, let's say, reflect this point, you will have to come down perpendicular to the line and see whatever movement you've done on this side needs to be replicated on the other side. So you see, I moved one box across, half a box across and one box across. That means 1.5 boxes across. So I'm going to do the same thing on the other side as well. So I can say that this point reaches here. So that's the first point that's reached. I'm going to erase that line now. I'm going to take that other point and go like that. So that's 2 boxes. So that's 2 boxes on the other side as well. So that point has reached here. And then there's the third point. Let's draw a perpendicular line. So that was 3 boxes across. So 3 boxes across. So that is my image. Okay. C, triangle C. So that's how you do a reflection. Let's move on to this question. It says triangle A is mapped onto triangle B and the point P minus 2 triangle B. Triangle A, triangle B and the point P are drawn on the grid. Describe fully the single transformation that maps triangle A onto triangle B. So this shows you that it's flipped. So it's just a reflection. Again, I can clearly see that in the x-axis. I can also draw and check. I just need to draw one set of lines and draw the perpendicular bisector. That's the perpendicular bisector. Then it says write down the matrix that represents this transformation. Again, you did this earlier, 1, 0, 0, 1, and then it gets transformed to what? This point would remain on where it is. So it would remain at 1, 0, and that other point, that 0, 1, would get transformed to 0, minus 1. So that should be the point. Then says triangle A is mapped onto triangle C by an enlargement P scale center P scale factor minus half on the grid. Draw and label triangle C. So triangle A is mapped onto triangle C. So again, what I'm going to do is I'm going to start measuring and seeing what the movement is. So this movement is minus 4 and 0. 4 and 0. So I'm going to say that this gets transformed to minus 2 and 0. So that point comes up here. I've moved minus 2 and 0 to this side. I'm going to erase that. Take another point. That's 4 and 2. So 4 and 2 becomes what? It becomes 2, 1. The movement 4 and 2 becomes minus 2, minus 1. So minus 2 and minus 1. That point is here. Then that's a long movement. How many units? 1, 2, 3, 4, 5, 6, 7, 8. So that's 8, 0, 8 and 0. So I'm going to say that it moves to minus 4 and 0. So that's minus 4 and 0. So that's the new shape that you have. It's triangle C. Make sure to label correctly as well. Then triangles A, B, C are drawn on the grid. Describe fully the single transformation that maps triangle A onto triangle B. Okay. Again, looks like a reflection. It's inverted like that. What I need to think about is, and I can see the orientation sort of has changed. It was, if I was moving from here, I was moving anti-clockwise, and now I'm moving clockwise. So that's change in orientation. That indicates a reflection. What I need to do is, now I can see that the reflection is no longer on this because these distances are not equal. So it's moved a little. So where is that moved? Let's draw this line and try to think where the perpendicular bisector would pass through. So that's where the perpendicular bisector would pass through. What is this line? This line is x equals to minus 1. So when I'm describing it, I'm going to say reflection in the line x equals to minus 1. Then describe fully the single transformation that maps triangle A onto triangle C. Now I can see that this one is a rotation. I can see that the shape has been rotated. It's sort of gone like that. So you can sort of guess that I've sort of moved clockwise. So I'm going to say that it's clockwise. Okay, transformations are usually either 90 degrees or 180 degrees. This looks like 90 degrees. I'm also going to verify that. I'm just making conjecture right now. Then the important thing about transformations is finding out the center of rotation. Now, to be honest, that's no simple job. You can sort of guess and then come up with an answer, because 90 degrees ढूंढना मुश्किल नहीं होता. But at the same time, what you need to understand is that there is an entire method. What is that method? You draw an object, an image, and you draw its perpendicular bisector. So that's one perpendicular bisector. You erase the object image line. Then you pick up another object and image. So let's say you want to pick out this one. And you draw its perpendicular bisector. Now, if it's a tilted line, you draw a perpendicular bisector with your scale, and you can use your set square as well. That sort of gives you the 90 degrees directly. I can see that the midpoint has to be this, and I'll just try to make it approximately 90 degrees. So that's approximately 90 degrees. Let's stretch it to the other side as well. So that passes through. Let's just erase the original line. So these two perpendicular bisectors, wherever they intersect is the center of rotation. So in this case, it's 0, 1. What I'm going to do is I'm just going to erase about center of rotation. 0, 1. So what I'm going to do is I'm going to erase these two and now show you that my hunch was also 90 degree 0, 1. Why? Because I knew it's 90 degrees, and when I thought about these 2 points, they were making an angle of 90 degrees. Then honestly, I didn't even think about these 2 points, but they also make 90 degrees. So that's how the center of rotation works. You can have a bit of a trial and error and sort of get to your final answer as well. Then triangle D is mapped onto triangle. Now you see 3 marks. They are divided by clockwise 90 degrees and center of rotation. So everything that you write correctly gets you 1 mark. So don't get lost on the center of rotation only. Try to focus your energies on all the 3 things. And even if you don't get the 3rd mark right, you're still getting 2 marks out of 3. Triangle D is the image of triangle A after an enlargement of scale factor with center of enlargement 1, 2. So once I've done all of this, I'm going to erase this. And 1, 2. 1, 2 is here. Oh, that's on it. So I need to do what? I need to do a scale factor of 2. So this original point remains as it is. This distance is 2, so it gets multiplied to 4. So this distance becomes larger. The original point is on the original, because this point had a 0 movement, so it's going to stay there. Then this point basically has a movement of 2 and 1, so it's going to get a movement of 4 and 2. So that's what the that's what the new shape is going to look like. That's triangle D. Okay, then another question. This one is also again about, I can see a rotation sort of happening. You can see that the shape has been rotated. Uh, is it a rotation? That's Yep, that is a rotation. It seems more challenging than the ones that we've seen before. So the center of rotation might be in a different position, which is why it's slightly more complicated. It is certainly 90 degrees. You can confidently say it's not 180 degrees. So it's 90 degrees. I don't right now understand whether it's clockwise or anti-clockwise, but let's try to find the center of rotation first. So I'm going to join an object and an image and think about where the perpendicular bisector would be. It's here. So that's the first perpendicular bisector that I have. Then I'm going to join another set of points. I think going to join this one because I see a movement of 2 and 2, and then I'm trying to draw a 90-degree line through here. Okay, it's difficult to draw 90 degrees without a D, but I'm doing the best I can. So that's a 90-degree line. Okay, so that is my center of rotation. What coordinates does it have? It has coordinates 1 comma center 1 comma minus 1. Now let's sort of try to analyze whether it's 90-degree clockwise or 90-degree anti-clockwise. So this point gets A is onto B, right? I was looking at the other say. A is onto B. Okay, so this point got rotated like that, so it's 90 degrees clockwise rotation. All the while I was looking at the other thing, so 90 degrees clockwise. I should have figured out that this has moved like that, so therefore it's clockwise. So I could get again 2 marks. It's not necessary that you get everything right on the exam to get an A, but you should try to do that. But on this, at the same time, you should be aware of where you should be spending your time. Transformation P is represented by the matrix this. P maps triangle A onto triangle C. On the grid, draw C. Now I can obviously see that this is basically an enlargement. So I could go on and apply an enlargement with scale factor minus half and get it done. But how do you move? How do you do transformations when you have the matrix? So it's transformation matrix multiplied by object matrix equals to image matrix. Now what do I mean by object matrix? I can write all the coordinates of A as the vertices of A as object. So minus 2 0, minus 4 0, and this one is minus 2 comma minus 4. And I could just do a matrix multiplication. Okay, how do you do matrix multiplication? You multiply like that. So if it's the first row and first column that you're multiplying, you get it in the first row and first column. So minus half into minus 2 plus 0 into 0. Then you take the first row and then you take the second row and first column. So that gives you 0 into minus 2 0, and that gives minus half into 0 also gives you 0. So the point that you're getting is 1 comma 0. So you could go on and plot 1 comma 0 here. I'm going to erase the rest of it so that you can see it clearly. 1 comma 0. So 1 comma 0. So this point gets here. Then I could do the next column. So minus half into minus 4 will give me 2. 0 into 0 will give me 0. So 2 plus 0. 0 into all of this second row and first column. That's how you do matrix multiplication. I hope you know that. Since this is not a video on matrix multiplication, I'm not going into depth on that. So that's that. And I can obviously see that minus half into minus 2 would give me 1, and 0 into minus 4 would give me 1. 0 and 0 and 2, that would give me 1 comma 2. So 1 comma 2. So that is what triangle C would look like. In case you don't know your matrix multiplication and you still want to draw triangle C, remember that whenever you are given matrices, the center is always 0, 0. So remember that. That's part of your syllabus. That's the restriction on the syllabus. So center is always 0, 0. If you've guessed that this is an enlargement with an enlargement factor minus half, that's your cue to move on. Okay, then let's look at this question. It says describe fully the single transformation that maps A onto B. That looks like a simple translation. What's the vector? It's how many movements? This is 1, 2, 3, 4, 5, -5 and 4. So -5 and 4. Always move on the x-axis first. That makes let's avoid silly errors that we make. Triangle A is mapped onto triangle C by an enlargement center 0, -1. So let's first mark our 0, -1 as the center, and it has a scale factor of 2. So again, movements 2 and -2, so that's going to become 4 and -4. So that point comes up here. Then 3 and 0, so that becomes 6 and 0, so that goes here. And I can obviously see that the line is here, so I can also guess and sort of, complete the shape. I know the shape is going to remain the same. It had to be on the same side of the center of enlargement because my center of enlargement was positive. So that's that. Then the last question for this video, I have described fully the single transformation that maps A onto B. Again, it's a translation. And the vector. So 1, 2, 3, 4 and -2. So 4 and -2. I should write translation with vector. But as long as you've written both the things, you will probably get full marks out of this. Then this triangle A is mapped onto triangle C by a 90 degrees anti-clockwise rotation about 0, 0. Now, since I haven't done any other question on center of on rotation, I'm going to give a little more time to this. Now, I showed you this. This was the first thing that I showed you. So remember, 90 degrees anti-clockwise rotation. You write your vector and then you switch the x and y coordinates, and you put a negative sign with the one on the top. If it's already negative, then it becomes plus and so on. So that's what I'm going to do in these questions as well. In this question as well, I'm going to measure the movement. I'm going to say that there was a movement of 3 and -2. So I'm going to first write 3 and -2. What happens? The coordinates first get switched, so -2 and 3, and the sign of the top coordinate gets changed. So when this point is rotated, it should be visible on this movement now. Where is this movement? Can I say that this is 2 and 3? So this point gets rotated and appears here. Let's look at another one so that you understand it better. Let's erase this and sort of draw it to another point. So that's 2 and -4. So I'm going to again write it in a convenient place so that I don't mess it up. 2 and -4. So first switch them, -4 and 2, and then change the sign of the one on top. Okay, so -4 and 2 becomes +4 and 2, so that should appear here. That's a movement of 4 and 2. Then the third one is this coordinate. So I have a movement of 3 and -4. So -4 and 3, and then change the sign. So 4 plus 4 and 3. You see, you've got your answer. Rotated 90 degrees anti-clockwise, center 0, 0. Okay, I can also show you how that movement is happening. If you look at this point, 90 degrees anti-clockwise. Let's see. Then this triangle D is measured by an enlargement scale factor 3. center 5 minus 5. So again, I'm erasing all of this. Center 5 and minus 5. That's here. And the scale factor is 3. Okay. So again, I'm going to measure the movements and then work accordingly. So that's a movement of minus 2 and 1. When both of these get multiplied by 3, so I get a movement of minus 6 and 3. Minus 6 and 3. So this point appears here. So then another movement is minus 3 and 1. So that gets moved to minus 9 and 3. So 3, 3, 3, minus 9, and then 3 up. So that's another point. Now, since this is pretty simple, you can, sort of guess that the third point is going to be like that. And since this distance was 2, it would get enlarged to 6. So I can draw it like that only. That's 6. That's the enlargement. So that's D. Okay, I hope this session was productive and you learned a lot of things for tomorrow's exam. Please make sure to like and subscribe for more paper 2 recordings as you prepare for paper 1 tomorrow, and then we will continue with paper 2. Thank you.